Dobar dan svima. Good afternoon, everybody. Is there anybody in the vicinity who is not a native Croatian speaker? Okay. So I'll do this talk in English then. First of all, thank you all for coming, and thank you. I wish to thank the sponsors, King ICT, who made this great conference possible. This is my second year that I'm delivering a talk here, and it seems great like the last year. So the talk of the day from me will be going TypeScript benefits of typed JavaScript development. So I'll do a little disclaimer up front. I'm not like a TypeScript zealot. The purpose here is not to sway you in the direction that TypeScript is the only way to go, which would be ridiculous. But I will tell you a little story of how we adopted TypeScript in our own company, which is called Prototype. It is a small agency specialized in creating custom interfaces based in Osijek, Croatia. We have 16 people. I'm the co-founder and CTO. So we do .NET backend development, a lot of infrastructure, Firebase, AWS, Azure, and we do React, Vue, and Angular. So we have a lot of JavaScript-based stack that we do. We have delivered everything from router interfaces to dashboards for embedded devices and so on. So what is TypeScript? It's an open source programming language, which is a strict superset of JavaScript. So what the heck does that mean? It means it's JavaScript, the base JavaScript. It has no changes, but it has some optional things that you can turn on. So when I decided that, and it's made by Microsoft, which the original developers were from Microsoft. Now it's open source, so the whole community is working on it. But I know a lot of people who were kind of disgusted by TypeScript because it's a Microsoft technology. Well, but who cares? I believe that we should use the best tools for the job. So from the developer mindset, when you start listening about something new, then trouble begins. When I tried to introduce TypeScript as a norm in our own company, and currently we do strictly TypeScript. We don't do any JavaScript without TypeScript anywhere. So it's front-end, back-end. We use it really everywhere. The only exceptions are cases where my company is embedded in a project from the client, who is the architect, and we don't want to change things and stuff like that. So I had a good deal of pushback when we started from my developers, and there are some misconceptions. First is I will need to learn a new language. So that one is totally wrong. So TypeScript has everything like it's in base JavaScript. The purpose of TypeScript is not to introduce features that JavaScript will not support in the future, because TypeScript is, at the end of the day, compiled to pure JavaScript. So what runs in your client's browsers, devices, and so on, it's pure JavaScript. It doesn't have anything to do with TypeScript. But on the development side, on the development machines, TypeScript will allow you some new functionality and a lot of syntactical sugar thingies, and I don't know, code completion support better, and so on. We'll talk about it later. But this statement is usually completely wrong. Development time will increase. Well, this maybe has some sense. When you start working on TypeScript in the company and you haven't done anything in TypeScript before, you will be slower. That's definitely so, because you will need to first adapt to some new norms. I need to write static types for every parameter. I need to define interfaces that say that my function will accept these parameters and stuff like that. So it is maybe a bit of an overhead. But on the other hand, the time in development is not only lost in the development itself of new features, it's often lost in maintenance. And when we are talking about maintenance, when you go back to a project that you haven't worked on for, let's say, 6 months, and you need to figure what the hell is going on, because you had like 5 projects in between and you don't know anymore, then TypeScript really shows its good colors, because you can go through your interfaces and static types and you can figure out very quickly what you need to pass somewhere, what is going on, and so on. So development time will increase, yes. Initial dev time, maybe. When you get up to speed and experience with TypeScript, I don't think this is true, but let's say it's a 10% maybe offset in the initial development time, but it's probably much, much more beneficial on the maintenance side. So at the end of the day, when you cross the line, you will probably save more time than lose by using TypeScript. Writing and maintaining static types is tedious. Of course, JavaScript is a dynamic language. Nobody wants to write additional stuff that you can work without. I mean, JavaScript works without this stuff, so why would I need to do it? And that's okay, but it's only a matter of perspective. The developers in my company who are like most concerned about us introducing TypeScript were usually the guys who never did backend. The backend crew generally understands static typing because it's kind of a norm in most backend languages. But front-end guys were like, I don't want to do it, it's tedious and so on. But now, 2 years later, they're like the most proactive members of the team who are learning everybody else TypeScript. And I had a situation, one of the developers, he always have a con in everything, but he's a great guy. So not long ago, he needed to do a small app without TypeScript, and he was lost. He told me he came to something. He is some of the things in the workflow that TypeScript gives him became so normal that he kind of was confused without them. So yes, I would say that this is maybe the initial thought for everybody, even the people who like TypeScript. I'm less efficient because the setup is too strict. I'll show you how a config for the TypeScript compiler looks like and how tslint file looks like. It's very similar to ESLint that you have on the base JavaScript. They are now even going in the direction that they will merge the two. So ESLint will support both TypeScript and base JavaScript through Babel, which is great. So this is more of a thing that you need to talk with your team about. If you disable everything in TypeScript, you will just have base JavaScript with no additions. You don't even have to write interfaces for properties. When you start introducing stuff that you want to enforce in your project, which is great, try to talk it through with your team. See if these things will really give you the benefit or they will start losing you time. And if you see that you enforce some rules that are very irritating, for example, you can make it so strict that even if you, let's say, delete a reference and you have an unused import up top, you first need to remove it because the file will not compile and so on, or you can disable this. It matters only what your team thinks it's most productive. Because that little situation when you're doing a lot of small testing can be, for example, irritating, but the setup is very, very easy to change. And one of the big concerns was that not all widely used frameworks support TypeScript, which was true until now. So Angular was definitely the first one that introduced TypeScript and made it kind of mandatory. React added it as an option a year ago. So you can now use TypeScript with both React and React Native. And Vue.js is getting TypeScript support with Vue 3.0. So I think that in Vue it will also be optional. You will be able to determine whether you want to use it or not. But this statement will be void from the start of the next year, I would say. So you can now use TypeScript with any framework that you want, the most popular ones. So, of course, at the start of the talk, I told you that I don't want to convince you. I just want to explain some cases that were happening in our company. So, one of the good things from my perspective is that popular SDKs and libraries use TypeScript or are written by it. What does it mean in practice? It means that you will lose a lot less time reading documentation for simple things. You will import the SDK, press a button, get a list of its models, functions, and so on. And in most scenarios, if you want to do something very trivial like authentication, you will figure it out of the box because it's well documented in TypeScript without really going to the website and reading a lot of documentation. The experience in my company is when we are working with SDKs for large providers and so on, they have a ton of features. Of course, you need to go and see the documentation to really go deep down. But our first case is always install the SDK. If it doesn't have types, see if they exist like a third party. There is a great website that's called definitelytyped.com, where a lot of developers contribute types to the libraries that are not their own. And you install the types, try to figure it out quickly. If you can't, go to the documentation. But reading tons of documentation without even trying the library is kind of maybe a thing of the past. Code completion support. I'll show it later on in the example. Code completion in TypeScript is, if I would need to single out one reason that should be enough to sway you in the direction of using TypeScript, that would be code completion. Because if you use the library written in TypeScript, you will have the whole IntelliSense thingy for all libraries that support it. But even some other things, when you import files in your project, Visual Studio Code that we primarily use, but I've used WebStorm, for example, they have such great support for TypeScript that you can simply start writing, let's say you write React, you can simply start writing the component name. The IDE will figure out whether you are using relative imports, absolute imports, named or default, and it will import the component automatically for you because you want to use it in the most optimal way. A lot of big companies have used or have moved their products to TypeScript. This doesn't mean that we all need to use it, because they have products which are far greater probably than the ones that we are working on. But it's a good case. If the big ones are doing it, why? Most of them are doing it to simplify the maintenance and refactoring of their code, if nothing else. So I was talking to one of the guys who works at Netflix, and they told me that when they ported from JavaScript to TypeScript, that they found a lot of small bugs that they haven't even seen before. Some syntax issues, semantic issues, whatnot, because the TypeScript compiler told them that they have, I don't know, null checks that they don't need to have, stuff like that. So they managed to even simplify and increase the performance of the Netflix app just with switch to yes. And you will probably learn more JavaScript internals than before. This might seem strange, But considering the TypeScript compiler can be a lot more strict than your default Babel setup, when it starts grinding you about stuff, you will probably take some time to really figure it out. Why is he complaining this works great in JavaScript? And then you see, aha, okay, I may have a racing condition, although code works, and stuff like that. As I said at the start, nothing is really forcing you to use the features that you don't want or need. And the next step. So what I will outline are enumerables, interfaces, generics, and some general configuration of the TypeScript. I switched to white to be more readable. Is it big enough? Okay. So the TypeScript config looks a lot like JS config that you can have with Babel. Some of the things are, let's say, a little bit more simple. For example, if you tell it that you have a root dir, which is also source, it will automatically activate absolute imports for all of your code in the source folder. So when you type a module name or a folder name, it will first look in the root folder and then fall back into node modules if it doesn't find what you need. So in Babel setup, this is a little bit more complex. You can either do local pack.json files in each folder, or you can set a node source environment variable, which will do the same. But in TypeScript, it's kind of more streamlined to be in the configuration. And you have a lot of some strictness options on the compiler level. As far as TSLint goes, as I said, it's very similar to ESLint. It does have some very specific TypeScript properties. But, for example, for interfaces, do you want to prefix them with, wrong one? Do you want to prefix them with the I letter like it's in .NET or not and stuff like that? So as you can see, we used the TSLint recommended setup and the one for React, because this is an example of the React project. And we changed and turned off a lot of stuff that we figured out as a team simply doesn't work for us. So there are a lot of options. If Airbnb does it or Google does it, they all have differences in their configs. That doesn't mean that you need to take their config and simply use them, and because it will be frustrating if it doesn't work for your team. So try to figure out what you want, what you don't want, turn off the stuff that you don't want, eliminate the overhead for you, and once you get more experienced, you will see better which things you want or don't. So one of the things that is specific to TypeScript, which doesn't exist in the base JavaScript, are enumerables or enums. They work like in basically any backend language. You can have numerical enums, string enums, combined enums. You can reassign their values, whatnot. This will compile to a rather specific JavaScript object. But what's great about the enum are two things. In JavaScript, an object, even if you assign it to a constant, means that you will not be able to change it from object to another data type, but its properties will still be mutable. You will need to freeze the object if you want to freeze its properties. With enums, if you use it for constants, enums are completely mutation safe, so they're completely immutable. You can use them in ifs, you can do a lot of things with them, but there is one great thing about the enum which doesn't work with the object. Okay, I didn't run the project, but you can do something like this, which will do a reverse mapping. So in objects, if you want to access the property key, you will need to use object keys, map all of the keys, or do a for each or something like that. With enums, if you tell him that you want the second property, you will get you would get a draft property name. But if you want to value, you could just access it. So it's a little bit more flexible than a normal object when you're working with constants. So apart from that, generics. I would say that in JavaScript, the normal way of taking a part of the logic and kind of making it generic is writing higher order functions. So, but the problem with higher order functions is often that if you need to query a few higher order functions in sequence to get to apply multiple mutations to some code that you want, it can get a bit of unreadable. So in TypeScript, you have normal generic classes. You also have generic functions, which allow you to simply send it a dynamic object. And it works really great with the, let's say, site of linting. Just a second. Okay. For example, the generic class for getting that says, give me a new database service. The model is the client, and the collection on Firebase will be company clients. And you can then easily do something like this. And I know that this item will be added directly to the company clients collection. Generics, you can definitely work with JavaScript without them, but if you want to have a more lightweight code, more single source of true code, and more manageable code, it's definitely a great pattern that came from like a full featured languages. So it's something that we use really a lot, especially when writing libraries. So we are currently in the process of creating a monorepo of private NPM packages that we will use in-house. So a lot of the code in that core logic is generic, so it can be easily integrated in our app clients. And the interfaces, which are like the first thing that you will see when you work with TypeScript. Does anybody here use React or Angular or some component library? Okay. So I have a pagination component that gets some properties. So it gets from its parent, the component gets some handlers and gets the state on which page we are on and so on. So you can see the pagination component here. Okay, so the pagination component in this case is dump or simple presentational component. All of the state it gets from the parent, so we can easily reuse it on multiple screens regardless of the data type. So when compared to the normal JavaScript with Babel and TypeScript, TypeScript does require you to define an interface which will say which are the data types of entry parameters, or if you have handlers, whether they are returning a value or not, and so on. So how does this really work? If you write the JavaScript without TypeScript, you can easily make a mistake here and maybe not figure it out immediately until your QA tells you, or things break in production. But with TypeScript, it's a bit more complex, because considering that we have defined in the interface what are the things that this component needs to have to really work, it will immediately tell you which prop is missing, and if you don't provide it, the stuff will not compile. So you will upfront these like stupid errors, you will resolve them upfront. And stuff like this usually saves you a lot of time if you need to write component tests. If you use code completion, you will also get, so the children and key properties are something that React gives you, and this is the prop that I defined that is, for example, still missing. It also goes the other way around. If I change the property, I tell it it's a string, all my views that use this component will break. And if you're refactoring code because you have a monstrosity of an enterprise software, you really want this to happen, because you will do a bug fix branch, you will fix all of the views that broke because you changed the property, and you will go on, and you will be rather safe. So this is, just a second to see how much time we have. Okay. I'll get back to the presentation. I didn't want to go into huge technicalities, but we can talk about it after the talk. So, are there any upcoming cool things? One is the safe navigation operator. If there are backend developers in the room, they are probably laughing. They have this for 20 years now. But unfortunately, the JavaScript is not going so great in that regard. But 4th of November, we'll get the safe navigation operator. Why is this a big thing for TypeScript and JavaScript? Because when you are accessing properties in an object, you need to do an if check for each level of a property if you have nested objects, or you simply use Lodash to resolve that stuff for you. But now you will get a way of defining in a single line, even if you need to go unlimited levels, which is the property that you really want to check if it's null or not. Top level await. Async await in JavaScript is not a new thing, but you needed to wrap an async function in a class or a function to really use it, which made JavaScript kinda stupid for scripts, because you needed to create a lot of functions to really use async await. Now this is changing. The await will now work anywhere. And null coalescing operator, another backend thing. So you have a pipe operator in the JavaScript, the 2 pipes. But the problem is that the pipe operator, or operator, if you want to call it like that, it does a falsy check. It doesn't do a null check. It does a falsy check, but a lot of things can be falsy. Empty string, 0. So it's not only null or undefined. The null coalescing operator will scope that to only null or undefined values if you want to check them, and the piping operator will remain working as it is as a falsy. So are there any issues? We didn't encounter any major issues, but there are some problems. You are, let's say, using React or Angular. You want to use a specific library, but the original developer of the library may be fucked up. So he entered types that don't correspond to the functions, and then you have a crazy situation where you have a lot of errors in the app that you might not be able to fix. And that's pretty much it. We didn't have any other issue, especially in the building the apps or something like that. And should you try it on the next project? It depends. If you are an enterprise company or you have an enterprise project, definitely yes. I will probably never again write any JavaScript without any form of static typing. It doesn't need to be TypeScript, but it needs to be statically typed. But if you have like a small project or a small team or which is maybe inexperienced, try to focus first on mastering the JavaScript, the base JavaScript side of things, because if you suck at JavaScript, you will suck at TypeScript, but it will be on another level, because you will have issues and you will not be sure whether it's TypeScript messing with you or you really fucked up with JavaScript. So that's pretty much it. Do you have any questions? We have a minute or two. If you don't have any questions, I would like to see any comments from your side. If you are using TypeScript, love it, hate it, something else? Okay. You can find me later in the hall so we can talk about it in private then. Oh, sure. No. I mean, TypeScript is a transpiler, to be honest, so I don't think that will change. And no, I think that the next state in the browsers are web components, which will run C# and some other languages directly, but I personally don't see that that will happen for TypeScript. Not sure why, though. Okay? That's it. Thank you very much. Have a nice day.